Hello, grade 12s, and welcome to another lesson on trigonometric graphs. Well done on getting this far. You have made amazing progress, and this section is quite exciting in the sense that it allows us to see how our equations, solving of equations, how that looks on a picture, on a graph. You'll see that although this section is called Trig graphs, the first two slides are actually spent on solving an equation and applying our identities knowledge. So it is actually quite incredible the way everything culminates in one lesson today. Let's have a look at this example. I've taken number D from exercise 4.12, which is your homework today. It was also your homework yesterday, so I am quite chuffed at the pace that we're going, and I really hope that you are coping thus far. Please let me know if you aren't. Right, so let's show that 2 cos theta equals sine theta plus 30 can be written as root 3 sine theta equals 3 cos theta. The only thing that we can really do here is apply the compound angle identity for sine. So let's go ahead and do that. Instead of writing sine theta plus 30, we can say 2 cos theta is equal to sine theta cos 30 plus cos theta sine 30. Now I hope that 30 degrees is shouting out to you, special angle, so we can go and substitute cos 30 and sine 30 with its actual values. So here we end up with 2 cos theta is sine theta times root 3 over 2, because that's the value of cos 30, plus cos theta times a half, because that's the value of sine theta. Since we're dealing with an equation over here, we can get rid of that denominator by multiplying every single term by 2, and that now converts the 2 cos theta into 4 cos theta. Look how we are getting a little bit closer to the outcome, because on the left hand side of the equal sign we have a 4 cos theta, and on the right hand side of the equal sign we have a positive 1 cos theta. Once we bring that cos theta over to the left hand side, we can simplify our terms, and voila, we've got the new outfit, the new appearance of that same old equation. Do you realize that the only really piece of information we applied here was the compound angle identity? It's really straightforward. The rest was just substituting and then switching a few things around, manipulating the left hand side and the right hand side a little bit. So I hope that wasn't too challenging for you. Now we are required to solve the equation 2 cos theta equals sine theta plus 30 for theta. Right, the word hence means use the information or the outcome of the previous question. So the previous question already tells us, even if you couldn't do it, if you realized you didn't know which compound identity to apply, or if you felt like you were struggling, don't worry about your actual working out from the previous question, but use the previous question's information. So we know that 2 cos theta equals sine theta plus 30 can be written as root 3 sine 30 equals 3 cos theta. So let's solve that equation there on the right. The root 3 sine theta equals 3 cos theta. Why? Because there are 2 thetas. They're exactly the same, which means we can divide both sides by cos, and we can solve an equation in terms of tan. Sine over cos turned into a tan, and cos over cos cancelled each other out, which left us with that 3 on the right hand side. Now if we divide both sides by root 3, we get tan theta equals 3 over root 3. Pop that into your calculator, arctan, to get a reference angle of 60. Now we should remember the formula for an equation of tan, because you've done general formula till you've been blue in the face. So you can tell me now that theta must be 60 degrees plus k180, and don't forget k is an element of integers. Righty, not so bad at all. Now I almost thought we were at the end, but then I remembered, have a look at the question, top right. We need to solve this equation for theta being an element of negative 180 to positive 180. So that this is a not so general solution. We are narrowing our interval down, and we are going to apply any k value from, say, 0. When k is 0, theta equals 60. So great, that falls into our interval. When k is negative 1, we're going to say 60 minus 180, and that gives us a negative 120. Cool, that also falls into the interval. If we were to add 180 to 60, we would get 240, and that's too big. So that doesn't fall into our interval, so we can call it a day. Theta is just negative 120 and 60 degrees. Now I cannot wait to show you the very next question. Right, so now we are required to sketch these two graphs that we've actually been working with thus far. These are simple sketches because there's only been one manipulation to the original cosine basic curve and the sine basic curve. The cosine is the same old shape, except now we are fluctuating between positive 2 and negative 2. Look at how the amplitude has changed. I also advise that you allow yourself to sketch the full curve. Get your shape of cosine looking really, really good. And then after the fact that you've got the full curve in the space of its normal period, 360 degrees, you can go and restrict the domain by cutting off the edges of the graph. To fall within that interval, negative 180 to positive 180. So sketch in pencil and then go and erase the part of the graph that you don't need. Also, don't forget to label your x-intercepts. And these occur at negative 90 and positive 90 as they normally do for a normal graph. We've just cut off the domain now. As for sine theta, we draw our normal uppy, uppy, downy, downy, but instead of starting at the origin, we are going to start that uppy, uppy, downy, downy at negative 30 degrees. So because this basic sine curve has been shifted by 30 degrees to the left, it's as easy as that. Only thing is, I've gone crazy here, sketching a whole lot of mountains and valleys, when in fact I need to restrict my domain to negative 180, from negative 180 to positive 180. Please take note, I've been a little bit inaccurate. See how my blue left part of my sine curve has gone beyond the negative 180 degrees. I'd appreciate it if you would erase everything up until negative 180 and be a little bit more accurate than what I've managed to be. Right, let's also label the significant parts. The x-intercept will now no longer be the origin as it normally is for sine. It's moved along to negative 130, and then the other one will be 30 degrees before its usual x-intercept, the usual x-intercept being 180. Now it will occur at 150. Okie dokes, let's see what else we can see from this. Oh, look at those beautiful points of intersection. Can you remember the previous question? The equation that we solved did not look like 2 cos theta equals sine theta plus 30. Yes, it had a different sort of appearance, but we proved that that equation solved in question 2 is the same as this equation given as the intersection points of this equation. So those answers that we generated in question 2 are actually just the points of intersection for the graphs in question 3. Is that not just too thrilling? Then question 4 requires us to interpret the sketch that we've just made, and that we do always. When you see inequalities, you need to think, aha, my answer to an inequality will always be a segment of the x-axis, okay? If they're asking determine the values of theta, excuse the lack of detail in my question. If you actually go look at this question in the textbook, it will have more detail. But this requires us to determine the values of theta for which 2 cos theta, the red curve, is greater than, in other words, lies above the blue curve, the sine theta curve, all right? We are looking for which segment of the x-axis will red be above blue? Because I don't see a 0 in this inequality, and I'm only asked where is the one graph above or below the other graph. The points that are significant to us are those points of intersection. So go and draw columns. Note that these are not asymptotes. This is just a vertical column for us to highlight the segment that could possibly be our answer. Right now, by drawing those two vertical yellow dotted lines, I have chopped up my x-axis into 3 parts: before the left yellow line, between the 2 yellow lines, and after the right yellow line. One or more of those segments will be my answer, guaranteed. So if you can just narrow down your x-axis in that way, you're already halfway there. Okay, now I'm really hoping it's popping out at you. Do you see between negative 120 degrees and positive 60 degrees, red is clearly above blue, and so that is our answer. Theta is an element of negative 120 to positive 60. There are round brackets in our interval, not square ones, because the inequality sign, the crocodile, I like to call him, does not have an equal to symbol. It is just where is cos merely greater than sine, where the crocodile does not have a double chin, so we do not include our lower and upper limits of this interval. Righty. Next part of the question asks us to determine the values of theta for which 2 cos theta divided by sine theta gives us a positive value. Now this, remember that they could also just pop the F over the G. So they're asking you, where is the quotient positive? In other words, in order to get a positive number, when you divide any 2 numbers, the sign of those 2 numbers that you are dividing needs to be the same. The same applies for product. So they could have asked this question where they were timesing the 2 graphs together. It's the same concept. We approach it with the same strategy. The red flag for me, or the alarm bell, or the, I don't know what, the cue is, the big clue maybe, is when you see a 0 in an inequality sign, then in an inequality question, then you must go and make columns through the zeros on your graph. What the heck is a 0? It is a solution. Another word for solution, an x-intercept, all right? Zeros, solutions, x-intercepts all represent the same thing. So now I have gone and removed my yellow columns just to make things a little more straightforward, and let's go and put black dotted columns through all the x-intercepts, all of cos's, the red graph's x-intercepts, and all of the blue graph's x-intercepts. Now we see that we have a lot of options here, so we need to maybe work through this a little bit slowly, but let's go through it left to right. Let's look at that first interval, from negative 180 to positive 100, from negative 180 to negative 90. Do you see that red and blue are both below the x-axis? That means their y values are both negative, and the quotient of 2 negatives will give you a positive. So that segment right there will most definitely fall within our answer. So negative 180 to negative 190. Then, from negative 90 to negative 30, red is above while blue is below, so we can't include that part. However, from negative 30 all the way to positive 90, red is above the x-axis, blue is above the x-axis. Thus, if you were to take any of their y values and create a quotient of the 2, you would have a positive being divided by a positive, which would give you a positive. Cool! So negative 30 to positive 90 is also part of my answer. Right, then last but not least, from 90 to 150, we see that blue is above while red is below. But then from 150 degrees onwards, so 150 to 180, they are both below the x-axis again. So we include that one as well. This was quite a detailed answer. And note that even though the inequality sign has a double chin. Our crocodile has a double chin. In other words, it's the product must be greater than or equal to 0. We cannot include the zeros whatsoever, because if we did, well, we cannot include the 150 as a 0, because if we did, our quotient would be undefined, because that is where blue, which is at the bottom of this fraction, would be 0, and we cannot have a 0 at the bottom of this fraction. I'm just double checking. Same applies for the negative 30. We couldn't include negative 30. We couldn't include negative 180, but the negative 90 and the positive 90 have square brackets because we could include those. All right, watch this video again. Pause where you need to take down notes. I know there's a lot of information that I gave verbally and didn't write down. So if you need to make detailed notes, please do. And enjoy your homework for today. I think you are going to be A-OK.